For this diagram, we can see that gravity is acting towards the center of this star. Now, massive star, they have nuclear fusion at their cores or their centers. So what happens is that hydrogen fuse together to make helium, and this produces a lot of energy. And then the core gets very hot, it generates pressure, and then the pressure acts outwards. So it's an outward pressure. And this balances the gravity. So it is this balance that keeps the star, in the shape that it is. So the star's gravity tries to squeeze into a very tight ball, but then nuclear fusion keeps the pressure from being squeezed tight. So both forces are acting against each other, and so therefore that's why it is balanced, and that's why you have a star. Now, what happens when nuclear fusion starts to end? So when nuclear fusion starts to end, the heat will becomes less, so there'll be less heat, it starts to cool down, and then gravity wins. And then that's when the star suddenly collapses. And when the star collapses, it produces an enormous shock wave. Normally, you have a dense core left behind. And what is a nebula? A nebula is where you have an expanding cloud of hot gas. For this diagram, you can have a look at the supernova as well, but we're looking at a black hole. So how do black holes form? So have a look at this diagram and tell me how black holes are formed. So you've got a dying star on the left, supernova on the second diagram, there's a collapse in the third diagram, and then black hole, and then a quasar on the last diagram. Okay, for this table, we have the planets on the left-hand side, and you got 5 columns of data. Now, the first column is the distance of the planet from the sun, and you need to look at the top. It says 10 to the power of 3 kilometers. And then the second column, radius, different planets have different radii, and then different planets have different masses in the third column. Now, in the last 2 columns, to focus on the one that's on the far right. So on the far right, where it says the G on the surface of the planet. So for example, if you look at Neptune, that will be 11.15. That is the gravitational field strength of that planet if you were on the surface of Neptune. Have a look at this diagram. So the one that's blue is quite close to 400 nanometers. And then have a look at the red. The red is about 700 nanometers. So it is the wavelength. Now, I have taught you what wavelength was when we did waves. So which one has the longer wavelength? Is it the red or the blue? Which one has the longer wavelength? Now, when we talk about redshift and blue shift, if something's moving towards you, it is blue shifted. And if something's moving away from you, it is redshift. So what does that mean? So have a look at the wavelength. The wavelength is 700 nanometers for the red, and for the blue it is about 400 nanometers. For this one, the sun is on the right this time. Now, instead of looking at the positions, just look at the names. So what is waning crescent? What is waxing crescent? What do you think first quarter is, and what do you think third quarter is? So if you look at this diagram, how can you explain the phases of the moon? For this diagram, you've got the sun on the left and the earth on the right. So here, can you see that the moon is going around the earth while the sun is still on the left? So why do you think there's a new moon between the sun and the earth? And why do you think there's a full moon when the earth is in between the sun and the moon? So why is it bright when it's at the full moon, and why is it dark when it's the new moon? And if you have the moon in other positions, why do you think you only see part of the moon? All right, so this is another graph. This is more colorful and more, I mean, there's just a diagram of the planets, the picture of the planets and the picture of the thermometer. Here you can just give a rough guide of the trend between the planets and the temperature. All right, and then for this diagram, you've got the pictures of the individual planets with the individual temperatures. Now, why do you think there's a range? So for one, it says Mercury. Why do you think there's a range? For Earth, why do you think there's a range? And for Mars, why do you think there's a range? And again, what is the trend of the temperature and the distance of the planet from the sun? What do you think the trend is? For this table, you've got the temperature of the planets on the y-axis, and you've got the planet itself on the x-axis. Now, can you see there is a trend? Which one is the outlier? Which one is the anomaly? Can you give a reason why that is the anomaly? And if you just ignore the if you ignore the anomaly, what is the trend? So what is the trend between the planets and the temperature? This diagram shows you a total solar eclipse. So the sun is on the left, the moon is in between the sun and the earth is on the right. So what do you think umbra means? What is umbra? And what is penumbra? What is penumbra? So what is the answer? Why do you think you get a solar eclipse?